Well, thanks everyone who expressed interest in my Tactile Z-Probe that I made for my little printer. I appreciate that, and especially those that ask if I could explain a little bit more about it. So I'd be glad to do that. So here I am. To start off with, just a quick recap, I'm using the latching solenoid off of a laptop DVD drive. I'll go into more details on that, but it's got a permanent magnet inside it that holds that rocking arm in place so that the spring tension, just barely enough, the magnet's just strong enough to hold that in place until you apply 5 volts to the coil, and that then releases the rocking arm so that the probe can go down. So that's the first half of it. And the second half is this small optical sensor down here that the rod, or the probe, I guess we'll call it the probe, has a notch in it that cuts through that optical sensor, and that's what you use to sense your bed. So how did I put all this together? It started by taking apart this DVD drive, and I saw this little tiny solenoid in here, and I could tell that it was magnetic, and started playing around with it and decided this is interesting. I bet you I could build something out of this. So I continued to mess around with it, try to figure it out, and I determined that if you put 5 volts on the coil, it will then release that latch. So now I had something I could work with to try to build. I immediately thought of a Z-Probe, actually. I was going to use this drawer switch here that was also part of the DVD drive. It was there and simple, so that was my first idea. But then I was taking apart this floppy disk, and I saw this sensor inside there. And a lot of the newer floppy drives, they've got a different sensor at a different location, but this was an older one, and it's got this 5mm optical sensor, and the flag that's attached to the read-write heads move into that sensor and determine the home position. So I saw that and thought, I've got to make this work. Here's a better view of that when it's pulled out. You can see the sensor, and I'm just going to leave it on that board because that would make it super easy to mount to something rather than try to remount that little tiny sensor on a different board. So that worked out really well. And by looking at the back of the circuit board, I worked out how the sensor is connected to the wires so that I can wire it for my own purposes. So if you've not worked with this kind of sensor before, this was pretty straightforward because of the job that I do. So I've got the 3 wire pads moving left to right, R, B, and Y, probably red, blue, and yellow. And follow the green line. That's the first trace that goes to the first half of that sensor, which is a light emitting diode, and the orange line traces that path back to the B terminal. So that's one circuit, and the other circuit is the from the R, you follow the green line over to the other half of that sensor. That is a phototransistor, which is used alongside the light emitting diode. So those are my 2 circuits and where my wires go. And if I draw this out, I can see a 5-volt circuit on that light emitting diode. I worked out that a 560 ohm drop-in resistor was sufficient to have enough light to turn on that transistor. And a 22k ohm pull-up resistor is used on the transistor output to make a good high and a low signal that my Arduino can read. So I connected that to my Z-Min end stop and set up all the appropriate Arduino code, obviously. So now when I pull use an M119 to pull my end stops, my Z-Min is triggered when my probe is pushed up, and it's open when the probe is moved down. So that's exactly how I wanted it to work. Go into your Arduino firmware. You can define pins debugging, which is a useful tool. You could use M43 to look at the state of your pins, of any of the pins actually. So I used an M43 P18 for pin 18, and then a W, which means watching pins. So now every time that flag or that signal changes states from a high to a low, then I get a report on the screen. So that's another interesting way you can look at your pin status to determine if it's working. So how do I get my solenoid to work now? I need to get 5 volts to it. So what I like to do in this situation is use the AUX2 pin header on the ramps board. I like it because it's 10 pins. I've got my VCC 5 volts, I've got a ground, and I've got 3 digital pins, D40, D42, and D44, all right there in one little package. And the command to turn a pin on and off is M44, so D44 just kind of naturally is my first place to go for that. So if I send an M42, which is the command to turn a pin on, and P42, and at a set point of 255, that will turn on that output. And correspondingly, if I use the same M42 command, the same pin P42, and a set point of 0, that will turn the pin off. So this is a simple way to turn that pin on and off. I can just put that in my starting G code. The kicker to all this is that there's no way that output can drive this solenoid. When you look at the specs for the Arduino, it's recommending a max of 20 amps and no more than 200 amps for the whole package. And this thing pulls 220 milliamps. So I need a driver. And the ULN 2003 driver package is made just for this kind of work, where it's meant to take a 5 volt TTL input and use that to drive a large inductive load like a motor or a solenoid or light bulb. That's what it's made to do, so it's perfect for this application. It's also got the built-in flyback diodes in there to capture any back EMF from the coil. And one thing to remember if you use this is that it doesn't output a voltage. It takes that pin, that output pin, and shorts it to ground. I'm not going to go into all the theory behind that, but just remember that when I show you the wiring. So the final diagram was using AUX2 and pin 42. I connected that to pin 1 of the ULN 2003 chip. Pin 8 went to ground. Pin 9 goes to my 5 volts, and I connected 5 volts to one side of my solenoid, and the other side of the solenoid goes to pin 16. And when I put 5 volts on pin 1, that connects pin 16 to ground and completes my circuit and activates my solenoid. I put all that together on this little tiny proto board that I had from somewhere. It's the perfect size for what I needed. I'm sure at some point I'll solder this all together onto a breadboard or a circuit board, but I like to move slowly to make sure things work okay. So I've got my 2 resistors for my sensor and my drive chip for my solenoid all right there in one nice package. So I got those 2 working. How do I connect it all together? This is the long drawn out part of it, because I'm showing you right here, I've used Fusion to design this, and what I did was use calipers and measure and replicate my solenoid and also my sensor board. So I knew what size they were, I knew what the dimensions of them, so I could start building around it. And then there's a joke about how do you turn a block of marble into a statue? Well, you just remove all the parts that don't look like a person. I just started making shapes and trying to replicate what the DVD drive was trying to do, and I added and subtracted until I had this shape. Now, I also printed probably 24 different prototypes to get to this point, because all of them didn't work in some way, or sometimes I'd print it just to test a concept, but this is the final version of it, and this probe rod, or whatever you want to call it, is that's the key thing right there. It's got that brown piece, that bracket that holds it, but when the solenoid releases that rocker arm and the probe drops down, there's a little notch cut into that. Let me move that down farther. And that's what blocks and allows the light through that sensor to say whether you are pushing against the bed or not. That is as simple as it gets right there. So that's the flag that works with my sensor, and The uh, parts all seem to hold up fairly well. I'm just using PLA for this. Uh, so far, it's been fairly durable. If it's not, I'll print another one. But I designed that backing plate to line up with the screw holes on my part cooling ducting that I designed. So I used bolts to mount that to the head, and so I just designed it to use a screw that was 4 millimeters longer, so I didn't have to redesign any of the other parts that I was using. So hopefully that's helpful. I'm not sure that it is. I'm sorry if it's not. So now we've got the whole thing assembled, and I've got my G-code in my starting G-code section, my M42 to turn on my solenoid. G4 is a dwell for 200 milliseconds, and then I turned it off again. And this worked. This is what I needed it to do. The only problem with that is that sometimes that probe didn't drop down while I was developing all this, and so it would do the Z-probe up in air, where, because the probe was sensed, it thought, well, I must be sensing the bed at every step. So it would do that, go through the probing, but I'm still, 70 millimeters in the air. So that didn't print very well, obviously. So I figured at this point, I really should have some type of a safety or an interlock in place so that if this thing didn't work, that it wouldn't continue to try to print like that. So I added to the starting G-code an M117, waiting for Z-probe. That just puts a message on the display to remind me if it doesn't print, why it's not printing. And an M226, which is a wait for pin status command. So P18 is the pin, that's my Z-min end stop, and I'm waiting for a state of 1 instead of 0. This did not work at all. I had to figure out why. So I went into my firmware and verified that my Z-min pin is pin 18. And I went and I used that M43 again to look at pin 18, and it says it's protected, so I can't see what the status is. So Marlin has a way of, they call it sensitive pins, and you can't do anything with the pins if they are protected like that. It just ignores the commands. So my Z-min pin is one of these sensitive pins, so I just took that out of the sensitive list and recompiled my code, so now Z-min is not a protected pin. When I now look at that pin status again, it shows me that it's an input of 1, and if I move the flag in and out of the sensor, then it changes state. So now this is working the way I wanted it to. So now the G-code does actually work as well. If the probe doesn't drop, it gives me the message on the screen, and it won't continue until the probe drops. And I can just reach up and push it down as well, but it's just a safety to make sure that it works right. One thing I forgot to mention before is this M48 repeatability test. If you've got that enabled in your firmware, you can check how accurate your probe is. And I meant to mention this before, is that if you run an M48, it will drop down onto the bed a certain number of times and measure the accuracy. And this is with this little sensor from the floppy drive, I've got a range of 13 microns, and my standard deviation is 4 microns. That's more than accurate enough for what I'm doing with this little printer. So that's it. That's how it all went together. That was really fast, I know. It was a lot of information. Feel free to ask me a question if you've got one. I'm not an expert at any of this, but I will answer any questions as best I can. I appreciate the interest in this, so thanks a lot for listening.